Welcome. I'd like to take you through some of the research performed at the University of Bristol in the Communication Systems and Networks group relating to wireless innovation in the APE project. My name is Professor Andrew Nix. The project started by looking at some of the work that was ongoing in looking at media streaming on the LTE standard, in particular some of the work that the BBC had performed at the Commonwealth Games. In APE, we wished to look at multimedia delivery, but for Wi-Fi tablets and smartphones. This technology was then embedded into WildEye to provide the world's first scalable platform for rich multimedia content on Wi-Fi platforms. Many people ask me, can't we do this already? Well, yes, Wi-Fi is indeed common with video transmission, but current apps tend to do this as a unicast service. And this is fine if you just have a couple of users, but can it scale to many thousands of users? To scale video content to large user groups, we need multicast services, and although this is used in the control plane, it is not exploited at present in Wi-Fi in the data plane. Multicast signals tend to be very unreliable. High packet loss rates are generally seen. Also, the firmware often gives you very limited control over the multicast service. So let me tell you a little bit about the APE access point and server. So looking at the diagram on the right-hand side, we started with a Motorola access point when we performed our first trials at Slimbridge. We then upgraded to Broadcom's devices at Bristol Zoo. With Broadcom's help, we managed to get our access point to work effectively with multicast. We then basically set about looking at a coding and distribution server to repacketize the data from the file storage and the cameras in order to reliably send it over the multicast systems. This diagram gives you a brief idea of the video subsystem. We have a camera which was then basically pumping IP packets which were repacketized, applied higher level application level coding using a RaptorQ code, and then put out into basically a network scheduler or a buffer. This diagram shows the idea. The original video comes out in various packets of large and small sizes. We repacketize them into fixed packet sizes and then apply an application layer code to produce the green repair symbols. If some symbols are lost on delivery to the mobile, we can then recreate them. And then from the vector coded stream, we're able to create the original packets of various sizes for play out on the mobile device. As far as the mobile device is concerned, it is unaware of the multicast process. So it's simply robust and reliable multi-channel video is then produced, which is scalable to many hundreds, if not thousands of terminals. We also didn't just want to do video, but we wanted to do a data subsystem. So here the idea is that data files are basically grouped into disks on a carousel. The carousel repeatedly transmits basically small parts of the data, and receiving terminals hopefully pick up all of the parts of a particular carousel. In practice, of course, some parts can be missing. We can also apply the RaptorQ codes in order to significantly improve the likelihood of downloading gigabytes of data from a cloud. It allows us to synchronize large data sets to tablets, a very important process for bring your own models. Our primary tablet was an Android platform. The Android platform required some low-level coding in order to do the Raptor decoding, in order to also convert the multicast to unicast on the video streams. For the data subsystem, we had to handle the carousel and then ultimately write the files back to the local memory of the device. Data logging was also a key part of our technology. The server logs every packet that is sent. The clients also log every packet against GPS coordinates and receive signal strengths. For data, we record the number of lost packets in the carousel. For video, we log the success rate on a per-second basis for each of the live video streams. Statistics can also be provided from groups of clients, and this can be allowed us to adjust the MCS modes and also the coding rate. So to optimize a complex system like this, we perform detailed simulations. Here you can see the GIS data for Bristol Zoo, trees, buildings and terrain. This was coupled with 3D antenna measurements for the access points and the clients that we were using. We then performed detailed channel modeling and Wi-Fi modeling, both for single antenna and multi-antenna MIMO systems. You can see in the left-hand picture here colored dots. Red is good, high signals, blue is bad, low signals. We looked at working out where best to place our access points to maximize signals to units. We then also show on the right-hand side some of the performance of how long it takes to download the 1.08 gigabyte disk into the users. We can see, for example, that after 10 minutes, over 84% of users have downloaded the data disk. However, with more traditional techniques, we would be somewhere in the region of about 75 to 80%. This led to a number of technical publications, as shown here, one on the carousel in PIMRC in London, and another in the IEEE Transactions on Mobile Communications, looking at efficient video. Here I look at the technical specifications of the final system that we demoed at Bristol Zoo. 5 access points were deployed. MCS Mode 2, offering a 19.5 megabit multicast rate, was used. We stuck with standard 20 megahertz bandwidth, 600 kilobits per video stream, 0.3 rate application layer coding. So here's a little short video. Here's the camera system feeding into what is an Apple laptop, which is running as our multimedia server. Ethernet from the multimedia server is then pumped into an access point. Here you can see diagnostics of the server's operation, and then feeding into an access point. In this example here, it's a Netgear 6300 running proprietary Broadcom firmware. Here we have 2 of the tablets. Both of them are running basically our APE application. So here you see we've connected to the live server on the app. The previous tablet next to it was already running. Remember, these tablets are receiving multicast services. So even though we have 2 tablets, we're only sending this video stream once from the access point. And in theory, we could have hundreds, if not thousands, of these tablets all receiving the same video. In fact, the camera will just pan around now and show a 3rd tablet, which is also receiving the multicast stream over here. So as you can see, this particular set of video can be scaled. So we could, for example, support TV channels being broadcast to groups of users at an airport or on a train or waiting in a public space. So this brings me to exploitation plans. I don't intend to take you through a robust treatment of every area, but I think within APE, we could either exploit the technology we've developed as an entire package. For example, we could produce a city guide app, or we could just look at some of the components. So, for example, just a video distribution service. But imagine what could you do if you could track users and you could provide live video and live data downloads of gigabytes of data to Wi-Fi-enabled customers and really scale it. This presentation covers some of the areas that we've been thinking about, but we're also interested to hear your thoughts, so please do get in touch. So broadcast television is an obvious area. Multicast Wi-Fi is ideal for streaming multi-channel television to large numbers of users. This could be in public spaces or maybe even onto public transport. Unlike Unicast, our multicast service will scale to hundreds of users per access point. Our APE system could provide easily 5 to 10 channels of high-quality video, as well as also providing standard internet connectivity. Compared to cellular, one of the big advantages is that Wi-Fi is an open technology. It's very easy for anyone to integrate this into a system offering. Another exciting area would be to look at, for example, in Bristol, how this technology could be used to enhance the Harbourside Festival. The WildApp app could easily be adopted here. And this makes a lot of sense because we are producing new Wi-Fi coverage based on the Bristol Gigabit network. Take a look at the Bristol is Open website for more details. We could offer live video, augmented reality, and many other exciting services to make the festival more exciting. Airports is another interesting area. Many people sit around with a lot of time on their hands. We could provide information, we could provide entertainment. For example, we could help people get to the right terminals and the right gates. We could do alerts on flight delays and final calls. Of course, also entertainment in the form of video could be offered. Shops and malls is a big exploitation area. We could do things like user tracking. For footfall statistics, we could also deliver targeted advertising and push personalized news out based off, for example, content that could be linked to a loyalty card scheme. We could also do things like Mal TV, providing information and guidance and also promoting various stores and offers that may be going on. And of course, many of this information could even be personalized to your specific usage through the use of the data carousel disks. Theme parks is another interesting area. Interactive maps helping you get around the place, augmented reality, live replays of your particular rides, location-based services. Footfall statistics, again, are very important to the people that run theme parks. For customers, live queue information, the fact that it may only be 20 minutes on one queue or an hour on another, very helpful information. Overall, this is very similar to the current WildEye app, would be a relatively easy installation. And finally, I'd like to talk about sports. This harks back to our original Visualize project, but again, we could offer video highlights, stadium mapping, an electronic match program could be provided, behind the scenes video, maybe addresses from the manager. And again, we could look at food and drink purchases directly to your seat using the localization information from your terminal. And at the end of the match, perhaps match highlights could be broadcast to your device for you to take away and keep as a memento of your visit. I hope you found this short presentation of our technology within APE of interest. If so, please do get in touch. My email here, or take a look at our Twitter account.